Alright, so this video here is to correct what we had problems with on the sensor. I was saying my sensor doesn't work. It works fine. Um, I just made a mistake on the code here. So let's first go to the main.c. I've modified this slightly. I've put the if statements here. Oops, I need to modify one more thing here. Put this into the for loop as well. Basically, I'm just wanting it to continually compute the temperature and pressure is the idea behind it. And then I'm going to go to the C file here because this is where the mistake was. And it was in the start conversion. And so what I did here is, and this is again making sure to convert these correctly. Let's get the datasheet back up here. And reading the datasheet carefully is that I didn't perform the convert command properly. So if we go down here, right here, so it says read coefficient, I squared read results, command to start conversion. So there's this one right here is starting the bus. This is the start conversion command, but then we have to send it an additional 00. Don't ask me why. I haven't read the datasheet carefully enough, but you have to send it an additional 00. So that's what we have here. We send the convert command, we send an additional 00, and then we delay by 3 seconds. And I said seconds, it's milliseconds, so we delay for the 3 milliseconds. Then we send our normal stop, point to the correct register, read the temperature data, and everything like that. So this one line here was what was preventing us, not that line, this line here was preventing us from reading the data in properly. And then there was a couple things that I had errors on here. Well, it would perform the calculations usually okay, but remember you want to cast these integers as floats because you're performing a floating point arithmetic here. So I did the same thing here with the thing there. So all I did was cast those as floats. So those are the only changes I made here. So let's get into the debugging again here. So let's go ahead and I'm going to go ahead and put a, that's a comment, put a breakpoint right there to start with. And then in the main.c program, I'm going to put a breakpoint here because we're going to show that the temperature and pressure do change. All right, so let's go ahead and put this in debug mode. No line 33. Because it's saying, hey, that's nothing's being done. So let me stop this here. Pressure is equal to pressure plus 1, temperature plus 1, because it's saying what it is like, well, hey, there was no real thing that you were doing here, so I'm just going to ignore it. But let's see if I do that now. Okay, yeah, so now it's successfully, because when it says pressure equals pressure, it's saying, it's like, well, that's a stupid line of code, so I'm not going to do that line of code. So now I'm doing pressure equals pressure plus 1, which, as a side note, is kind of irrelevant because we're just using this as a breakpoint to see what the temperature and pressure is from the sensor reading. Notice here, actually, we can notice here, I set temperature and pressure to 0. Notice that in floating point arithmetic, they're actually not 0. Which is actually something that's important to recognize. That's kind of an interesting little thing there. So what am I doing here? I'm going to hit the play. So I've read all the coefficients in, and now I'm into starting to read the pressure data. So if I do a step over here, we can see that yes, I have now read data in for my pressure. And if I step over again, we can look at, and I'll put these in binary here. And we can see, okay, well, I need to, put this one in binary. We can see that this data read has been stored into the pressure, but now I need to do the bit shift, so I'll step over. It does the bit shift. I'll read in the next byte of data, and there's the next byte of data read in. Then I put it on there, but now remember we had to bit shift all this to the right, and so I'll step over one more time, and we can see that it bit shift everything to the right. Great. Now we're going to read the pressure data in, and you can see that the pressure data is getting read in, and we're doing all the bit shifting properly. And now we're doing our computations. So it did the computations here, 73.29 for the compensated pressure. And then what I'm going to do is I'm going to expand these, because now we're going to actually compute the pressure. I'm taking that breakpoint out. So we get 99.13. So that's where you might have seen on my calculator here, I had 99.13 kilopascals to inches of mercury. So it's 29.27. So let's look at Fort Wayne barometric pressure. And depending on where you're looking at local conditions, and this one right here says it's 29.99. So what are we getting? 29.27. And which one's accurate? They're both accurate, because the pressure is not going to be constant everywhere. It's going to be small variations. You know, you're inside a house versus being outside. So yes, they're both correct. Great, awesome. And then let's step over one more time to see what the temperature computation is. So it's saying it's 23.79, if you round it, degrees Celsius. So let's do this here. So we have 23.79 Celsius to Fahrenheit. Which this one is definitely not accurate here. It says that my house is at 75 degrees, which is not accurate. But this is where, remember we talked about it, is that the temperature one, we have to actually perform a few more measurements. Like we have to have, to calibrate this one properly, this slope formula, we know we actually have to see what is it reading at 25 degrees Celsius and everything. So there's some small things you can do to adjust this formula, but yeah, so it's not 75 degrees, so that's not horribly accurate. But what we can do here, that just doesn't seem right. 23.79 should not be 75 degrees, should it? Because room temperature is 25. I guess no, it is right. So anyway, what we're going to do though is I'm going to put my finger on this. So I'm going to hit this so I can see what the temperature and pressure is, but I'm now holding my finger over the temperature sensor. So basically I'm using the heat of my finger to warm up the temperature sensor. And so I'm going to do there, and oh look, it's 27.7, and the pressure has increased because, well, I'm applying some pressure on there. Temperature is, so let's see if I breathe on it here. Yeah, so I just breathed on it there with my awesome breath there, and I jumped it up to 33 degrees Celsius. But then you can see it's not necessarily a fast response, but it is cooling down now as I take more measurements. So, and then the next thing you can do here is, again, you can tie all of these I2C devices together, so you could use your LCD screen and actually output what those pressure and temperature readings are. Which, wouldn't that be awesome? I think that's awesome.